Hey, ladies and gentlemen, good morning. As promised, we're going to do a video on just some of the problems that were requested from yesterday's integration review sheet. And there were only 3 problems requested, and so we'll go over them. So to start out, we have here, this is problem number 4, and we have this integral, okay? And it definitely looks a little complicated. But in general, if there isn't, at least for AB Calc, if there's an integral that doesn't look like it can just be directly done, then likely it's a U-substitution problem. And that's the case here. So you notice that we have a composition of 2 functions times another function. But as it turns out that the function that's inside here, you'll notice that if you take its derivative, it'll be a cubic, which that's what the outer function actually is. So this lends itself very nicely to U substitution. And so my choice of U will be that inner function, or that inner expression. So negative 2x to the 4th minus 4. And from here, of course, I need to differentiate. So I have du is equal to negative 8x to the 3rd dx. Now, this is not exactly what we have on the outside, but I do have an x cubed dx over here, which I can replace with something. I'm just going to move the negative 8 over to the other side. So I have du over negative 8 is equal to x cubed dx. All right, so now that x cubed dx that I have right over here, I'm going to replace it with du over negative 8. This is negative 32. It's a constant, so I'm going to pull that out front. And actually, at the same time, I'm going to pull the negative 8 all the way out front. So I have the negative 32 over negative 8 times the integral of, all right, well, this negative 2x to the 4th minus 4, that was my choice of u. So I have a u to the 4th. Again, the 32 I pulled out front, and that x cubed dx, I'm just going to simply replace with du over negative 8. But again, that negative 8 I've already pulled out front. All right, and so this integral just becomes something now that's pretty straightforward and simple to solve. So let's do that on the next line. Obviously, negative 32 over 8 is a 4. And the integral of u to the 4th du is u to the 5th over 5 plus c. And of course, my final answer, though, should be in terms of x, since this is an indefinite integral, and I was given an original integrand in terms of x. So my final answer should be in terms of x. So I will write this as 4 times negative 2x to the 4th minus 4, all of that to the 5th power, all of that divided by 5. And plus c over here. Now, I did distribute this 4 to both of these terms, but 4 times a constant is also just a constant, so you can leave it simply as plus c. You could also write it as plus 4c, it's up to you, but it's not incorrect to just write it as plus constant. Boom. And there you have it. That's your final answer. All right, moving on. So this is the first, number 6. Yeah, apologize for the numbering, but probably at this point you're used to this type of stuff with me. I definitely miss certain little details. But anyway, this is an interesting problem. This is a type of problem that actually the AP loves to give. Well, on a normal year, you're guaranteed to see a problem like this on your AP. I'm not exactly sure what the AP exam will look like this year, but rest assured, you know, there is a chance that you'll see something like this on the AP. But I want you to notice the pattern. So we want to evaluate this. All right, so let's just look at that first. Notice that this is a composition, f of x squared, times some other expression, x. But take a look, that expression x happens to be the derivative of this inner function, or at least it's a factor of the derivative of the inner function. Kind of like what we just saw up here, where we had an inner function whose derivative was a factor of the outer function, right? When I differentiated that inner function, I had a cubic. Similarly, when I differentiate this inner function, I'm going to have a linear. And so this is actually perfectly set up for us to do U-substitution. Okay, so I'll take my inner function and use that as my choice of U. And I will differentiate. So du is equal to 2x dx. So I have an x dx in this integrand. So I'm going to want to replace that with a u expression. So I can rewrite this as du over 2 is equal to x dx. So that x dx term will be replaced simply with du over 2. So moving on, let's write this. All right. So x dx, again, is going to be replaced with du over 2, but I'm going to pull the 1/2 out front. All right. And now what we have left is f of u. So I need to integrate f of u du. The one thing that we have to pay attention to also is that our limits of integration are no longer with respect to x, they should be with respect to u. So my -2 lower limit, when I plug it into my u equivalence, I get -2 squared, which is 4. So my lower limit is going to be 4. And my upper limit is still going to be 0. All right. So now let's evaluate. So I have 1/2 times the integral. So the antiderivative of little f of u is big F of u, evaluated from 4 to 0, right? And moving down, I have 1/2 times big F of 0 minus big F of 4. Okay, you might be asking, well, where do you go from here? Well, let's look at the given information because we haven't used that yet. Let me change the color. So I'm going to take this expression over here, and we're going to sort of analyze what that information actually is telling us. We're told that this expression is equal to 1. Well, fundamental theorem of calculus tells us that this expression can be written as big F of 4 minus big F of 0. And again, we are told up here that that is equal to 1. Well, take a look. In the parentheses over here, we have big F of 0 minus big F of 4. Well, that's very similar to what we have over here on the left, except it's sort of reversed. So if I multiply both of these, the left side and the right side, by -1, I have big F of 0 minus big F of 4 is equal to -1. Well, there you have it. This is the key that allows us to finish this problem. So because the fact that big F of 4 minus big F of 0 is equal to 1, that tells me that big F of 0 minus big F of 4 is equal to -1. And now I can use that information right over here. And I end up with -1/2. All right, so that's a pretty tricky problem. The first thing you need to do is recognize that this is a U-substitution problem. Carry it out as far as you can, which is really up to here. Once you get to this point, you need to figure out, well, then what is big F of 0 minus big F of 4 equal to? Typically, they will give you information that will allow you to figure out what that is equal, what that difference is equal to. All right? Okay. There you have it. Moving on. Okay, so a few people asked about 5D here, and I will definitely go over that. I'm going to quickly go through all 4 of these steps since this is an actual part 2 AP problem, and I just want to make sure that we are all on the same page about like how we solve a problem like this. All right, so a lot of important information is given in that first sentence, even though it might not sound like it. F is a function which is twice differentiable. So the fact that the function is twice differentiable means the function itself is continuous, and so is its derivative. So the function and its derivative are continuous, and of course we just have certain points along this curve. All right, part A asks us to estimate f prime of 4. Well, let's say you're given a curve f prime of a certain point, let's say here x equals 4. We don't know the y value. F prime of 4 is the slope of this line. Well, I don't have enough information to get the exact value. So what I'm going to do instead is choose a nearby secant line. Well, the closest secant line that I can find is, well, I have the points 3, 4 and 5, -2, right? I'm taking that directly from the table. If I connect those dots here, again, and by the way, I don't necessarily know that this is what the curve looks like. I'm just sort of drawing this out so you get the theory behind what this problem is asking. So, and obviously, yeah, you can clearly see that this scale is not perfect because this y value is supposed to be lower than this y value. But again, it's just a matter of the understanding. So I have I have a tangent line. I don't know its slope, so I'm trying to approximate that slope. So I use a nearby secant line. So I want to find the slope of the secant line. And of course, that's change in y. So -2 minus 4 over the change in x, 5 minus 3. Okay, and so like I said, yes, my diagram is showing positive slopes when they should be negative, but this diagram is simply so you get the idea. So we would say that f prime of 4 is going to be approximately -3. And that would be that answer. All right, part B. We want to evaluate this integral. So it's a definite integral from 2 to 13 of 3 minus 5 f prime of x dx. All right. So I definitely see a fundamental theorem of calculus coming into play here. But what I'm actually going to do first is kind of rewrite this integral into 2 separate integrals. So I'm going to write this as the integral from 2 to 13 of 3 dx minus 5 times the integral of 2 to 13 of f prime of x dx. And really, if I wanted to, I can pull this 3 constant out front here and just think of this as 1 dx. All right, and now fundamental theorem of calculus tells me to find the antiderivative. Well, the antiderivative of 1 dx is just x, and I want to evaluate that from 2 to 13. Oops. Right, how do I know that I found the correct antiderivative? Well, I should be able to take the derivative of my antiderivative and get the integrand. Well, the derivative of x is definitely 1, and so I'm sure that I have the correct antiderivative. All right, over to here, minus 5. Well, what is the antiderivative of f prime? Well, the antiderivative of f prime is just f. And of course, I'm going to evaluate that from 2 to 13. Okay, now we just sort of evaluate. So I have 3 times, 13 minus 2 minus 5 times. So I need f of 13. Well, luckily the table gives us that information. 6 minus f of 2, which is 1. Now it's just, of course, a matter of simplifying. So I have 13 minus 2, which is 11. 11 times 3 is 33. Minus 6 minus 1 is 5. 5 times 5 is 25. And your final answer here is 8. All right, that's part B. Part C, left Riemann sum. All right, so I'm just going to write the expression. I'm not going to evaluate, but basically the idea is, okay, we're looking to integrate f of x from 2 to 13. That, of course, is exactly equal to big F of 13 minus big F of 2. We don't have any of that information on the table, though, so I can't actually evaluate. But I also know that a definite integral is equal to area under curve from x equals 2 to x equals 13. Well, how do I estimate area under curve? Well, I do so by using a Riemann sum. So we can say that the integral from 2 to 13 of f of x dx is going to approximately equal, in this case, a left-handed Riemann sum. And we are forced certain subintervals. So this is going to be one subinterval. Here's the second. Here's the third. Here's the fourth. So with each one, I have to pay attention to the dx. So here, delta x is 1. But from 3 to 5, delta x is 2. From 5 to 8, delta x is 3. And from 8 to 13, delta x is 5. All right, and I'm going to use the left endpoints in each step for each rectangle's height, okay? So the first rectangle will have a height of 1, the second rectangle will have a height of 4, so on and so forth. So remember, the y value represents the height of the rectangle, the change in x represents the width of the rectangle. So my first rectangle is just 1 times 1 plus 4 times 2 plus negative 2 times 3 and yeah, a negative height sounds strange, but it just really means that the curve is below the x-axis, and so a rectangle is going to be below the x-axis, which is no big deal. And then we have 3 times 5. Okay, and you can do the rest on your own, but that's the idea there. Okay, all right, now part D, this is the one that people really were asking me about. So I'm gonna go ahead and draw a little bit more of an accurate diagram here. So I know that reading this problem, a lot of information given, but it's really not that bad. So suppose f prime of 5 is equal to 3. All that means is that the tangent line at x equals 5 has a slope of 3. We're also told that f double prime of x is less than 0. Sometimes people write this off as like unimportant information, but this is actually a key to the entire problem. The second derivative being negative tells us that the curve is concave down on this interval. All right, and this is the interval between 5 and 8. So I know that this curve will be concave down on this interval. And I have to use the tangent line to show the tangent line to the graph at x equals 5 to show that f of 7 is less than or equal to 4. And then I have to use the secant line to show that f of 7 is greater than or equal to 4/3. Sounds complicated, but if you just take it step by step, it is not so bad. So let's first try to get an idea of the diagram. So we're only focused on the interval from 5 to 8. So that's the part of the table that I'm gonna take points from. So I have the point 5, -2 and the point 8, 3. Let's draw a little XY axes. So I have the point 5, -2 and 8, 3, I believe. Let me double check real quick. Yep, 8, 3, okay. And remember, we were told that the second derivative is negative over this entire interval. So I have to connect these dots with something that looks concave down. And there we have it. Let's draw a bigger point just to help myself out. And there we have it. So this is what the diagram looks like. I now am asked to use the fact. So I want to use the tangent line to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. And remember, we're told that f prime of 5 is equal to 3. Okay, let's draw that tangent line. Okay, so I'm doing my best to draw a tangent line, but whenever you mess up, just draw a very big point so it looks like you drew a tangent line. All right. Sorry, I keep scrolling up because, okay, f of 7 is what we're interested in. So let's say f of 7 is somewhere around here. That got ugly real quick. Let me use a different color anyway. So here's my tangent line. Okay. So we are going to use this tangent line to show that f of 7 is less than 4. The thing is, since our curve is concave down, I know that any tangent line I draw will be above the curve. So notice that this red point that I just drew is greater than, its y value is greater than the y value of f of 4. So here's the point 4, comma, f of 4. Notice that the y value of the red point is greater than the y value of the function. So what I need to do is find the equation of the tangent line. All right, we were told that this slope is, I'm going to double check, is 3. All right, so the equation of the tangent line can be written as 3 times x minus 5 is equal to y plus 2. That's just point slope form of a line. And I know that this red line, this tangent line, has a slope of 3, and it has the point 5, -2. So now I'm going to distribute and simplify, and you can see that y is equal to 3x minus 17. And this y is what I'm going to use as my linear approximation. So let's just say L of x is 3x minus 17. And I'm going to use this linear approximation to approximate f of 4. So L of 4 would give me, oh, sorry, L of, why did I say f of 4? Sorry. I'm trying to estimate f of 7, my bad. So let's go back. This is actually the point. Seven, comma, f of 7. Sorry about that. So anyway, when I take my linear approximation and evaluate it at 7, I get 21 minus 17, which is equal to 4. And what you notice again, so this is the point 7, comma 4, and therefore 4 is greater than f of 7. All right, so we've proven that this very first statement. Okay, so certainly if 4 is greater than f of 7, well then 4 is also greater than or equal to f of 7. Okay, so that's step 1. Now we just need to do the same thing, but with the secant line of the line segment that connects x equals 5 and x equals 8. So let's go back down here to our diagram. Let's use a blue curve for the secant line. And this is going to get a little bit ugly with overlapping values, but it's okay. Here's my secant line. You'll notice that the secant line, again, because of the fact that the curve is concave down on this interval, the secant line exists completely below the curve. So the secant line approximation is going to be an underestimate, and that's exactly what we're trying to get at here. So the secant line, I need to determine its slope, change in y, which is 3 minus -2, over change in x, which is 8 minus 5. So this is 5 over 3. So I have the slope, and I also have a point. I'm going to use, once again, the point 5, -2. So for the tangent line, I have 5 over 3, so that's the slope, times x minus 5 is equal to y plus 2. This ultimately will give you y equals 5 over 3x minus 31 over 3. And this is the line that I'm going to use as an approximation for the function again. Since it's a secant line, let's just call it s of x. So s of x is equal to 5 over 3x minus 31 over 3. And now I evaluate that at 7, right? Because I'm trying to approximate f of 7. So s of 7 is equal to, well, 7 times 5 is 35. 35 minus 31 is 4. So s of 7 is 4/3. And as you can see, so now this we know is the point 7, comma 4 over 3. And as you can see, this is below the actual function. And so this value is less than f of 7. Okay, and there you have it. We have now proven both of the statements that 4 is greater than f of 7 and that 4/3 is less than f of 7. And there we have it, right? That's exactly what we were looking for. Boom, there's that second statement. All right, so part D, definitely a lot more complicated than the other 3 steps, but get used to that because the AP loves to give you problems that are pretty decent, especially like A and B should be not too much of a trouble. C sometimes gets a little tricky. Part D, that's where things are really, you really need to know your stuff. All right, so this one required a lot of knowledge of like linear approximation, finding the equations of lines, knowing how a tangent line relates to a concave down curve, knowing how a secant line relates to a concave down curve. So a lot going on there. But anyway, hopefully this helped. Of course, any questions, feel free to ask. And this video is already long enough, so I'm just going to end here. All right, folks, take care.